Hello again, everyone. Welcome back. Mr. Reeves with you today as we are going to be looking at solving systems of equations by substitution. More specifically, we're going to be doing some problem solving. So this is the third video involving solving systems by substitution. But today we're going to be focusing on solving problems and then setting up the systems and then solving the systems by substitution. So it's really more of a problem solving video than a substitution video, but that is the method we're going to be using once we solve the problems. All right, so here we go. We're going to go ahead and start with this problem right here. If you have your book out and you wanted to follow along, we're on page 243, and this is problem number 12. It says Angelo bought apples and bananas at the fruit stand. He bought 20 pieces of fruit and spent $11.50. Apples cost 50 cents and bananas cost 75 cents each. All right, so we're going to be writing a system and then using that system to try to find how many apples and how many bananas that he bought. So if you got a chance to watch my video on problem solving with the graphing method, it's actually going to be very similar to what we're doing now, except in that video we solved, once we had the system, we solved by graphing. Now once we have the system, we're going to solve by substitution. But when we have this system, we should have two equations with two variables. All right, so we're looking for two equations and we're looking for two variables, meaning there are two things that we don't know, and then there's two pieces of information that we do know that are going to help us find what we don't know. So if we read this problem carefully, actually, if we skip down right here, it says, tell how many apples and bananas Angelo bought. Usually when you're looking to figure out what your variables are, a good place to go is to the end of the problem. Kind of weird. You start by going to the end. You start by going to the end. So we're going to have two variables, and it's going to be how many apples, or the number of apples, and the number of bananas. Now, traditionally, we use X and Y for our variables in a system. I'm going to go ahead and use A and B. So A is going to be the number of apples. Okay, so A is the number of apples, and B is going to be the number of bananas. It's always a good idea to write down what your variables are, so when you're done, you know what it is you found for. And if you use a letter that represents what it is, that can make it easier too. So that's why I chose to use A and B. So A is the number of apples, right? B is the number of bananas. All right, so now we're going to look for two equations. Let's go back and see what they told us. It says Angelo bought apples and bananas. Yeah, we're good. All right, he bought what? He bought 20 pieces of fruit. Well, what is that fruit made up of? It's made up of bananas and apples, right? Bananas and apples, and he bought a total of 20. Now, we don't know. It could be 10 and 10, right? Could be 15 and 5. Could be 19 bananas and only one apple. Maybe he really loves bananas and doesn't like apples. We don't know. But we do know however many apples he bought plus however many bananas he bought, it's a total of 20. So apples plus bananas is 20. So this is our number equation, right? Again, more often now we use this for hashtag, but it means number. And then we're going to have another equation that's going to be our cost equation. That's the dollar symbol. Didn't come out very well. Let's try this again. Guess that's a little bit better. So our cost equation, we have 20 pieces of fruit, but how much do they cost? Well, it says that apples cost 50 cents each. So for every apple that he buys, it is 50 cents. Now we could write 0.50, or you can leave that 5 off. Because it's money, I'll put that on there. So 50 cents for every apple. Does that make sense? If he buys one apple, it's 50 cents. 2 apples would be $1. 3 apples would be $1.50. You would put the number of apples there and multiply it by 50 cents. All right, how much are those bananas? Those bananas, because everyone knows a banana is better than an apple, they cost 75 cents each, and that's 75 cents per banana. And then what is this total going to be? Here, I'm going to erase this. What is this total going to be? Well, how much money did he actually spend? He spent 11.50. You'll notice, by the way, I didn't put the dollar signs on. We don't usually put dollar and cent signs in an equation. We'll put those back on when we get our answer. So again, just a reminder, we have two variables. Our two variables were the number of apples right here and the number of bananas right here. We used those variables to write two equations. We had our first equation, which was the number of fruit, the amount of fruit, and then our second equation was the cost of the fruit. And so now we have this system that we can solve. And the method we're going to use, because that's the section we're in, is substitution. Now, in the method of substitution, remember what we want. We want one of our equations usually to say x equals or to say y equals. That's our goal. We want to isolate a variable. In this case, we want one of our equations to say a equals or b equals. So we look here, and when you have two equations with two variables, you always have four choices, right? You could solve for that first A, that first B, that second A, or that second B. And it's completely up to you what you choose. Now, I've told you in the previous videos, the best idea is to look for the videos where the variable in front is where the coefficient in front of the variable is a 1. It looks like nothing's there, but it's actually a 1. So in this case, it could be either this A or this B. All right, so I'm going to go ahead and isolate that A. So I'm going to go A plus B is equal to 20. And I want to get this A by itself. So what am I going to do? I'm going to subtract B. And when I do that, what do I get? I get that the number of apples is equal to 20 minus the number of bananas, which should make sense because if the apples plus the bananas adds up to 20, if you want to know how many apples there are, you should subtract the number of bananas from 20. So now we've solved, this is our first equation. Again, this is our number equation rewritten, our number equation rewritten. So now we can go into that second equation and replace A, right? I can replace A with what A is equal to right there. So here we go. So I'm going to go 50 cents times the number of apples. But what do we know about the number of apples? I'm going to need some more space here. All right, so 50 cents times the number of apples. But what is the number of apples? The number of apples, it tells us right here, is 20 minus B plus 0.75 B is going to equal 11.50. So 50 cents for every apple, but we replaced A, right? We replaced A with what A is equal to right there. So now I'm going to go ahead and distribute there. And when I do that, 50 cents times 20, or 0.5, half of 20 is 10. So I get 10 minus 0.50b plus 0.75b is equal to 11.50. And now I'm going to go ahead and combine my like terms. I've got 0.75b or 75 cents per banana minus 50 cents times b right here. When I do that, I get 10 plus 0.25b, right? Because 75 minus 50 is 25, but it has a decimal on it. And that's equal to 11.50. Running out of space here. Now again, this is great. We went from two equations with two variables to one equation. So we had A's and B's, now we only have B's. We're cleaning it up, and now we're at this equation right here, which is a two-step equation. To get that variable by itself, I'm going to go ahead and subtract 10 from both sides, and when I do that, I get 0.25b is equal to 150. And finally, the last step is I'm going to divide that 150 by 0.25. So the question is, in $1.50, how many quarters are there? Does that make sense? Well, I hope you know that if you have $1, it's 4 quarters. If you have $1.50, it's 6. So what did we just find out? We found out that B is equal to 6. And if you've forgotten, B was the number of bananas. So the number of bananas is 6. So 6 bananas. We have done the hard part. We are almost done. Because what was our first equation? Back up to the very beginning. What do we know? That there were 20 pieces of fruit. What did we just find out? There were 6 bananas, right? And what does that mean? That the number of apples is 20 minus the 6, right? If they have to add up to 20 and we've already used 6, we got to take that away. And I hope you know that 20 minus 6 is 14. All right, so we're saying that the answer is 6 bananas and 14 apples. All right, now what would a good math student do? They would check their answer because remember, we had two equations, right? We knew that the total had to add up to 20 and we're there, but we also know that the total money has to add up to 1150. So let's go ahead and do that and let's see what we get. All right, so 6 bananas and each banana cost how much again? All right, 75 cents. Actually did this in the opposite order of the equation. We're right here, right? But I wrote the answer 6 bananas. So 6 bananas at 75 cents each plus 14 apples at how much was an apple? 50 cents each. And when we do that, what do we get as a total? We get 11.5, which of course is the same as $11.50. All right, so we started off by identifying our variables. We used the information in the problem to write two equations. Again, you're going to see this a lot. There's going to be an equation about how many there are and an equation about the cost. We wrote those two equations. We solved the first equation for A, right? We isolated that variable. We plugged that into the second equation, solved that to find out there were 6 bananas. Used the fact that they had to add up to 20 to say 20 minus 6 is 14. And then we checked our answer with the second equation and found out that indeed it equaled $11.50. All right, I hope that made sense to you. Let's go ahead and do one more problem here, the one right below it. It's a different problem, but you're going to see it's actually very similar. All right, problem number 13. Again, we are on the same page. That page is 243. Problem number 13. A jar contains N nickels and D dimes. There is a total of 200 coins in the jar. The value of the coins is $14. How many nickels and how many dimes are in the jar? So can you see how this problem is very similar to the ones we just did, the one we just did, but instead of apples and bananas, now we have nickels and dimes. So once again, I'm going to start with my variables because remember what we're looking for. We're looking for two variables, and then we want what? We want two equations out of there, right? So here we go. So the variables, again, when you're looking for what your variables are, when you want to know where to start, go to the end. When you want to know where to start, go to the end because that usually tells you what you're looking for. How many nickels and how many dimes are in the jar. All right, so the number of nickels, right? We're going to call that N. So N is going to equal the number of nickels, and I bet you know what we're going to call the number of dimes. D is going to be the number of dimes. All right, so those are our two variables that we have. N for the number of nickels, D for the number of dimes. Now let's go back to the problem and see what they told us. Do we know how many dimes and nickels we have? No, but do we know how many together that we have? Remember with apples and bananas, we knew that there was 20 pieces of fruit. Well, now when we look here, what do we know? We know that there's a total of 200 coins, right? A total of 200 coins right here. So my first equation is going to be right here. The number of nickels plus the number of dimes is going to be 200, right? Again, in the previous problem, it was the number of apples plus the number of bananas was 20. Now it's the number of nickels plus the number of dimes is 200. We have 10 times as many coins as we did fruit. All right, so that's our number equation. Do you remember how we had a number equation? And do you remember what our second one was? It was a cost equation, right? Or a total amount of money equation. All right, well, what is a nickel worth? A nickel is worth 5 cents. So on the previous problem, they had to tell us how much they're charging for an apple or a banana because that could be different depending on where you're buying it, right? But a nickel is always worth 5 cents. So be careful. 5 cents is not zero point 0.5. As we did in the previous problem, that's 50 cents. So 5 cents is going to be 0.05. So 5 cents for every nickel plus a dime is worth what? 10 cents? 10 cents for every dime gives us the total of our money. And what is the total of our money? It says right here, 14, right? And again, we don't usually put dollar and cents in our equations. We don't usually put dollar and cents in our equations. So we have our two variables. N is the number of nickels. D is the number of dimes. We have our first equation, which says there's 200 coins total. Our second equation says there's $14 total, but that's made up of nickels that are worth 5 cents and dimes that are worth 10 cents. And so what are we going to do now? Now we're ready to solve. And the method we're going to use to solve is substitution. And once again, in substitution, what do we want to do? In substitution, we want to get one of these variables by itself. And again, we have four choices. We could solve for this n, this d, this n, or this d. Which one do you pick? You pick the one that's easiest to solve for, and you want the one, preferably, if there's one available, where you have a 1 there. So once again, we have two choices. There's a 1 in front of this n, and there's a 1 in front of this d. So I'm going to go ahead, just like I did in the previous problem, and I'm going to solve for that first variable. I'm going to try to get that n by itself. All right, so I'm going to go ahead and subtract d from both sides, and when I do that, I get n is equal to 200 minus d. N is equal to 200 minus d, which should make sense. If they add up to 200, right? If you want to know one of them, subtract it from 200. So the number of nickels is 200. Take away the number of dimes. So for example, if there were 100 dimes, we'd have 100 nickels. Or if there were 50 dimes, we'd have 150 nickels. All right, so that gives us our first equation and tells us what n is. So now we're going to go to our second equation here, but we're going to fill in what n is equal to. So n equals 200 minus d, and we're going to put that right there. Right there. We're going to replace that n with what n is equal to. See, n equals this, so that's what that n is going to equal. All right, so here we go. So we're going to go 0.05, but we're not going to put n. We're going to put 100. Sorry, not 100. 200 minus d, right? 200 minus d plus 0.0 or 0.10, 10 cents for every dime, and that equals $14. So we rewrote this second equation, but we replaced n with 200 minus d. And what do we now have? We went from two equations with two variables to one equation with one variable. And now I'm ready to go ahead and solve this. Okay, I'm going to simplify first, and I'm going to distribute. All right, so if you happen not to know how to do this problem by hand, let's go ahead and use a calculator. 0.05 times 200, and we get 10, which shouldn't surprise us because 0.05, for those of you who know, is 1/20th, and 1/20th of 200 is going to be 10, minus 0.05d plus 0.10d is equal to 14. So we're getting there. We just distributed, so we're cleaning this up a little bit. And now we're going to combine our like terms. I have right here what amounts to a negative 0.05 and a positive 0.1. So what's 10 minus 5, guys? 10 minus 5 is 5, but because I have more positives here, I'm going to get 0.05d, right, is equal to 14. Then I'm going to go ahead and subtract that 10 from both sides. I get 0.05d, all right, is equal to 4. And then I'm going to divide. So how many nickels are in $4? Well, I hope you know that there's 20 nickels in $1. So in $4, it'd be 20 times 4 or 8, right? All right, but if you don't believe me, let's go ahead and do that right now. Let's go ahead and do 4 divided by 0.05 on our calculator, and we get 80, right? Wow. Because Mr. Reeves wasn't being careful. 20, 20 nickels in $1 makes 80, not 8. Oh my goodness. Always a good idea to check your work with a calculator. See, there I was trying to impress you by not using a calculator. Goodness gracious, Mr. Reeves. All right, so what did we just find, guys? What did D stand for? All right, we've kind of scrolled down here. D was the number of dimes, right? So we now know that there are 80 dimes. But how many nickels are there? Well, what do we know? There's a total of 200 coins. What does it say right here? If you want to know the number of nickels, subtract 200 minus the number of dimes. Well, I hope you can do 200 minus 80 without a calculator. I don't know that I can because I'll probably mess up again. But I'm pretty darn sure that 200 minus 80 is 120. So I am thinking that there are 80 dimes and 120 nickels. We already have made them add up to 200 because if you add those together, you get 200. Again, a good math student is going to check their answer. We're not going to stop till we know for sure we're correct. So 80 dimes and 120 nickels, we're hoping for $14. So let's go to our calculator here. 80 dimes. So 80 times, what is a dime worth? A dime is worth 10 cents, right? Plus 120 nickels. What is a nickel worth? A nickel is worth 5 cents. And when we put that all in, what are we looking for? We're looking for $14. And wow, there it is. $14. We made the first equation true. We made the second equation true. All right, so just to summarize the process, when you are solving these equations, the first thing you need to do is you need to identify your two variables. How do you know what those two variables are? Usually they tell you at the end of the problem, the two things you're trying to find out. Then you're going to use the problem to create two equations. Many times, not always, but many times, your first equation is going to have a total number of things, and your second equation is going to involve money or value. Once you've created those two equations, you're going to solve for one of the variables. You'll always have four choices, but look for that space where that's a 1, where the coefficient is a 1. Solve for that variable. Then use substitution to put what that variable is equal to as an expression into the second equation. Simplify, solve, get your answer for the first variable, plug it back in to get the answer for the second variable, and then when all is said and done, check your answer to make sure it's correct. All right, I strongly encourage you to go ahead and go into the Personal Math Trainer and try doing these problems in the Personal Math Trainer. They will be very similar, but they'll be using different numbers, and that would be a way for you to see if you really understand how to do this. All right, thanks for watching, everybody. Have a great day.